right. Well, good morning, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Gorowski, and I'll be your host for today. We are almost done with October. I can't believe how fast this school year is going already. That means our space exploration events are wrapping up within the next day or so. If you've been joining us, you know we've been talking to astronauts and researchers, engineers, and talking all about what it takes to leave the planet, explore the solar system and beyond, but of course, turn that lens back on our planet and look at the Earth in ways we never could before. So we're not quite done yet. We still have a couple more space exploration events, including tomorrow when we'll connect with retired NASA astronaut Terry Virts, and we'll hang out and we'll learn about his explorations off of our planet. And just because October is our space month doesn't mean we won't mix in space-themed events throughout the school year. So there's still time to hang out with some cool space people as the school year continues. If you haven't visited the site recently, exploringbytheseat.com, we just launched a big series of events with CNN's Called Earth coming up next week. So check out those events. I think you'll find something for every classroom there, exploringbytheseat.com. But let's get into one more space exploration event. So I'm really excited today to have Professor Sara Seager joining us, Canadian-American astrophysicist and professor of physics, planetary science, and aeronautics and astronautics at MIT, where she holds the class of 1941 professor chair. Her research ranges from foundation of exoplanet atmospheres to innovative theories about life on other worlds to development of novel space mission concepts. She now leads the Morning Star missions to Venus in search of signs of life in Venus's clouds, which is pretty darn cool. And Sara joined us way back early on in Exploring by the Seat of Your Pants and talked to us about exoplanets. So it's really cool to have her coming back for another session. Let's reach backstage, see if we can get her in here front and center. Hey, Sara, how are you?
Hi, good morning to you, Joe, and to the classrooms. Hi.
All right. Well, Sara, it's great to have you with us. It has been a while since you hung out with us and talked exoplanets, and today we get to talk pretty cool, a planet sometimes dubbed Earth's evil twin. Let's talk a little bit about Venus today.
Let's do it.
All right, perfect. So to the classrooms tuning in, don't be shy to use the YouTube chat sidebar. Send us in some questions. Let us know where you're tuning in from. And then we've got a class or two kicking around backstage. We're going to bring you in as well for some Q&A action. But Sara, I know your screen is shared and ready to go. So let's hang out for a bit.
Well, I hope some of you have been able to see Venus in the night sky. I took this picture a week or two ago in the early morning, and you can see the crescent moon here. Can you see it? And you see Venus is shining so brightly. Sometimes you can see it at night. So please ask your teachers to make sure the next time, I'm sure most of you are not waking up at 5 a.m. or 6 a.m. But if you are up when it's dark, look in the eastern sky for Venus. And probably a few months from now, you can see it at night. And yes, Venus has sometimes been called our evil twin sister. Venus is about the same size as Earth and about the same mass as Earth, but it's completely different from our planet. Now, it is so hot. I bet you've learned in school at some point that the surface of Venus is so hot, it can melt lead. And so the surface of Venus, life can't survive on the surface. But what is interesting about Venus is just like on Earth, if you ever read about people climbing up mountains, like Mount Everest, it gets really cold high up above the Earth's surface. If you ever go in an airplane, and if you ever get to go in an airplane, you can look on your screen and see how high you are and what your temperature is. So just like on Venus, above the surface, it gets colder and colder. And way far above the surface, at 50 kilometers above, it's the right temperature for life. So even though the surface of Venus is too hot for life, way above the surface, it's the right temperature for life. Not only that, but that altitude where it's the right temperature, there are clouds. And these clouds are made of liquid. So life needs a liquid, it needs the right temperature, and it needs an energy source, the sun. So kind of technically speaking, all of the right ingredients are in the clouds. And we think that's why half a century ago, Carl Sagan first proposed there might be life in the clouds of Venus. Now, we're not imagining birds flying around butterflies or anything complicated. We're thinking if there is life, it's just like microbes, like the most primitive kind of life you can imagine. And just for comparison, there is some life in our clouds, but that life probably doesn't want to be there. It's little bacteria that get swept up and just stay there for a short time till they're rained out. And one more interesting factoid about Venus, the clouds are permanent. They're not fragmented. They don't come and go. They're always there, and they're very deep vertically. They're always present. So that was all the good news. But the bad news is the clouds are not made of water. The clouds are made of something called concentrated sulfuric acid. It's a chemical so dangerous to us humans, to all life. Unfortunately, you will probably never be allowed to use sulfuric acid in school. Sometimes when I talk to older people, like say your parents or grandparents' age, they'll have used sulfuric acid, but all the rules are like so tight now that no one's allowed to touch it because it will burn a hole in your skin. And this is an artist's conception of Venus. It looks pretty nasty. It's kind of dark and yellowish orange. But I do have like a video to show you, and I'm going to try to explain this video to you. This is me in my laboratory in another building here at MIT. And I have sulfuric acid in a bottle, that white bottle with the orange cap. Now, that's not in a cloud form, it's in liquid form, but we think the clouds of Venus have liquid sulfuric acid. On the right side, there's an infrared view, so you can see how hot it will be. And on the far right is a little cartoon of DNA. Now, all of our life on Earth has the DNA molecule. It is like what it means to be life is to have our DNA. And our DNA has a lot of components, but one of the components is sugar. So to show what can happen to Earth life, we're not going to put like a bug in sulfuric acid. We're not going to put like a mouse in sulfuric acid because that would be evil and mean. And no, we're not doing that. Instead, we're just going to use boring sugar. But in your head, you're supposed to be like sugar is part of DNA and DNA is part of life. Okay? So we're going to watch the video. And this is what happens to life. Although just as I mentioned, to keep it safe and sanitized and not hurt anything, we're just going to use sugar. So in that glass jar, it's just like the sugar you'd have in your house for baking. Here's the video. We have sped it up by 2.5 times so you can watch the reaction. So that sulfuric acid, again, it's like supposed to represent Venus clouds. And the sugar is supposed to represent our life because it's part of our DNA. Now look on the right side at the infrared. What is happening? It is getting hot in there, very hot. And look what's happening to that sugar. It is turning brown. Not good, people, not good. Now, whoa, it's heating up rapidly. This reaction is generating heat. And now that sugar is unbelievably growing into a giant porous structure. Kind of looks like a rock, but actually it's pretty soft. And on the right, you just see how hot it is. This is sugar, literally we say getting dehydrated. There's water vapor coming off. There is sulfur dioxide coming off. And at the end of the day, we basically have carbon left over from the sugar, and all the other parts are basically gone. Now, if that doesn't look kind of violent for life, like I don't know how else to convince you that on our planet, our life can't survive in the clouds of Venus in sulfuric acid at all. So what would you do about this? Well, I think most people, and I think that's why, even though a small group of scientists kept the idea alive, there could be life in the clouds. You know, most people just have to assume that we cannot have life in the clouds. But I really love to explore. And that wouldn't stop me from exploring in the laboratory. So what my team does is we do experiments in the laboratory. That's me in the background. In the foreground on the far left is Dr. Rachna Agrawal. She's now professor in India, where she's from. I put a couple of pictures of me in the laboratory. And on the bottom left, there's a picture from a special place in Indonesia where there's a very sulfuric acid lake. And on the right, that's myself and one of my team members, Yero. And that's a picture of us in Hawaii. So we have like a lot of lab experiments because we're trying to see that even though our life can't survive, we're demonstrating that some components of our life can survive. Perhaps some of you have heard of amino acids. We have taken our amino acids. Those are the very most basic building blocks of proteins and of life. We put them in concentrated sulfuric acid, and we tested them in chemistry machines. And we found that our amino acids, with one exception, are stable in concentrated sulfuric acid. So there are building blocks of life that are stable. Some are chemically modified, but they are stable. I'm not expecting you to understand this very scientific plot, but this is the kind of thing we would show to other scientists to convince them that our data is legit and that this actually is a fact. So our DNA is not stable. We saw the video taking one component of our DNA called sugar, and we showed it is not stable. But our goal is to create a DNA-like molecule. So taking our DNA, but swapping out parts. Just like if you had built a Lego structure and it's going to topple over, you need to bolster it up by swapping out some parts or making some add-ons. So we have a molecule, it's not called DNA, it's called PNA, peptide nucleic acid, and it doesn't have a sugar molecule in it. And we have shown that a single strand of this is stable in concentrated sulfuric acid at room temperature. And there's so much research we've done in the laboratory, it would take a long time to unpack it all for you. But I did want to tell you one more cool thing that our extended team has done. We took little lipids, these very small molecules, and they have what's called a polar head. And people put them in water to try to understand the origin of our life on Earth. And these polar heads, they like point outwards and they make a little tiny sphere made out of these lipids. And why are people doing this in water? Because they're trying to understand how our life arose. And because we have cells, we have compartments, we need to understand how compartments could form. Well, we took some of these lipids, and some people also did this a few decades back, but we found they form little tiny spherical vesicles. So these lipids, they're not only stable in concentrated sulfuric acid, but they also form little vesicles. So on the left here, you see these circles. This is just a picture in a microscope where we have put in some dye, which is also stable, and incorporated into these little vesicles. And yeah, the fact that if this didn't work, you would just see a blank screen. But the fact that you're seeing like these spheres that are super, super tiny, they're only what's called 10 microns across, it is all good news. So we are really excited. We have a lot going on in the lab. And for like the first time ever, we're demonstrating, not that life can survive, we're not saying that. We're just trying to say that our building blocks can survive, some building blocks. So to summarize this first half of my presentation, Venus clouds have the criteria for life. They have liquid in the form of these concentrated sulfuric acid cloud droplets. There's energy from the sun and suitable temperatures. And the takeaway for this part of the talk is that sulfuric acid actually can host biomolecular building blocks. It can host and wow, we are not saying there is life in the Venus atmosphere. We're saying it is worth sending space missions to Venus to look for signs of life. There's a lot of plans to go to the Venus atmosphere. In the past, the former Soviet Union and NASA, they sent combined like over a dozen probes went down into the atmosphere. But since 4 decades ago, 40 years, we haven't sent any probes into the atmosphere, although we have sent orbiters. And I'm not here to talk about the NASA missions or the European Space Agency missions, because let me tell you that the search for signs of life or life itself in the Venus atmosphere, it's still too crazy of an idea for large government agencies to support. So we have struck out on our own, and I am proud to be leading a group we call Morningstar Missions to Venus. Remember the picture I showed you? When Venus, it is right now shining so brightly in the morning sky. That's why we're calling it, it's not a star, but people used to think it was a star. It's so bright. So we're just thinking of the Venus bright future. And we want to send a series of small missions to Venus that each build upon the last mission, and that each mission can give us more evidence for complicated molecules in the Venus atmosphere. So I picked a couple of missions to tell you about. Our first mission to Venus, it's actually called the Rocket Lab mission to Venus because a company called Rocket Lab is going to launch the rocket. Inside the rocket will be a cruise vehicle, a spacecraft that will go to Venus. And inside that spacecraft will be a probe. And inside the probe is a pressure vessel. It's like a series of Russian dolls. And finally, on the inside is the instrument that I was responsible to fundraise for and have my team build the instrument built by Daryl Baumgartner at Cloud Measurement Solutions. So I brought a model to show you, a full-size model of the probe that we're planning to send to Venus. So Joe, can you see this?
Yeah, I put it nice and full screen.
All right, this is a 3D printed model. This is not going to Venus. It's just like a model, but it's full size. Nice, huh? And in the screen behind me, okay, well, we can come back to that later. There's a real picture of the real one. So this is fake. It's just to show and tell. The real one is in a very special clean room where it can't get dirty and people's like skin and hair can't fall on it. Now, when this goes to Venus, it's like throwing a rocket Venus. This whole thing is just going to get dropped off and it's going to be going very fast. And it will just slow down in the atmosphere due to its own drag and will spend 5 minutes in the clouds. Now, it's not going to open, but this model opens so we can see what's inside. So I'm going to open it and take this lid off. And you can see that and inside is this. See this? This is a pressure vessel to keep the pressure uniform as the probe goes down through the atmosphere and experiences a lot of different pressures. This here is our antenna. We'll be sending data directly to Earth. And inside this little thing, which is bulging out here, is going to be the science instrument. And it's a single science instrument that weighs 1 kilogram, and it'll be shining a light through this window. And we can go back to the presentation now. It will be, now you can see in the presentation, the real one, the real picture of it. It's got a very special heat shield on, because if you drop it into the atmosphere, it will be going so fast that without this special heat shield layer, the whole thing would burn up. So it has a special heat shield on the bottom and the top. And see, there's a little hole here. Our instrument will shine a light through the inner pressure vessel window and through the hole in the probe, and it'll be lighting up the clouds. We call it fluorescence. Like if you go to a fun house and they have like a UV light and your white clothes might light up. And we'll be looking to see if the clouds fluoresce, because if they fluoresce, it's a good indication that there's organic material in the clouds, which would be amazing. We're also measuring the backscattered polarized radiation, which holds information about the composition of the cloud particles. And honestly, one of our main goals is just to make sure it's not pure concentrated sulfuric acid. It's like as if we picked up some river water. We want to make sure it's not pure water. We're hoping that there's something interesting in there, like some complex molecules that might indicate there's life there. So that's the Rocket Lab mission to Venus. We have a lot going on. This is just kind of for, I'm going to speak quickly so you don't need to understand this to understand the rest of the talk. But on the top right is a picture of the instrument. That's a photograph of the actual instrument. On the left, the team has put it into a drone. It's like a light aircraft, and we've been flying it around. This picture is from Hawaii, flying it around in the outskirts of the volcanic fog to test our instrument. And on the right, there's lab testing and algorithm development. So we're pretty excited about this mission. We have a target launch of 2026, which is next year. The windows to go to Venus are about every 18 months. So if we miss our next launch, we wait for about 18 months. So for the last part of my talk, I'm going to talk about what we hope is going to be mission number 2 to Venus in this kind of private-public partnership. So unlike NASA, unlike European Space Agency, we just have like a singular goal and a singular instrument. And here we aim to send a parachute. Now, instead of just lasting 5 minutes in the cloud, it can last up to 1 hour in the cloud. And what we want to do with this parachute mission is have some brand new miniature molecular sensors, like a puzzle piece targeted to match up with a specific molecule they're designed to target. And we have a list of all the organic molecules we think could be stable in the Venus atmosphere, like the amino acids, like nucleic acid bases, a whole list. And that's our goal. So this parachute would be dropping down and the sensors would be on the bottom, shown on the left here at the bottom. We'd have these patches, which would be the miniature molecular sensors. Now, to get to space, if you wanted to build something to go to space, it takes like 100 steps. Like you have to do 100 different things. And we took our first step this summer, and I want to tell you about that first step. We wanted to send up, wait, 1 second, okay? I've got to grab one more thing. We wanted to test this box of sensors. Can you just show the, can you see this now, Joe? It's a box.
Yeah, we got it. Yep.
These are all actually, they're not sensing molecules. They're sensing temperature, pressure, and humidity, each one of these. And we wanted to just test out the idea of how do you have a lot of sensors? Ultimately, we want 10,000 sensors. We just started with 30 here. And we decided to test them by sending it in our atmosphere. So we couldn't send it to Venus because this is just the first step. When we get to like 100 steps, we'll be able to go to Venus. And here's a picture of one of my students. She's doing a master's degree here at MIT in Aeroastro. And she designed a parachute to go to Venus. She ordered this polyester. She made a design of it. She laser cut the strips. She sewed it up. And we put her parachute onto this weather balloon. And here you can see, this is actually a 14-year-old helping fill the weather balloon with hydrogen. Here's the team. And here's the parachute. Here's a box with some camera. And the box is going to be attached to the parachute. And here's what I just showed you on the left, the box of miniature molecular sensors. So what we did with this whole experiment in August, we launched it all. And by the way, there was a summer camp here at this Amateur Weather Balloon Society. And that's all the kids who got to come out and watch the launch. Do you see the parachute? It's kind of hard to see. It's this orange thing here. And in that box is our sensors. Now, our balloon went really high. It went like way higher than an airplane goes. Our balloon went to 70,000 feet above Earth's surface. And on the right, that's a camera that was on our payload that took that picture way high above. And in the middle, we're just showing you some tracking software where we had to chase the balloon. It lasted about 2 hours. It went up, it went down. The parachute worked, the sensors work. It landed in a tree. We tracked it, we found it, and we tested our sensors successfully. To summarize the second half of my talk, my team aims to send small focused missions to Venus. These will complement the bigger missions that I know you've heard about other missions, like to other bodies in our solar system, but this is different. This is very advanced, very risky, very small focused missions. And these miniature molecular sensors are a new concept for planetary evolution, and we're working hard to accelerate their development so they'll be ready to go soon. Now, just to summarize, I talked about our sister planet Venus. Its surface is too hot for life of any kind, but high above the surface in the clouds, it might be the right temperature for life. I hope that you'll keep everything in mind, that to explore, you really need to keep an open mind. And people might be stuck with their ideas, but with science and laboratory work, you have a chance to prove people wrong and to open up new horizons. Thank you for your attention today.
All right. Thank you, Sarah. That was a great presentation. I especially love that demonstration of the sugar in the sulfuric acid.
And by the way, while we're waiting for questions, I have to get back to the screen. While we're waiting for questions, someone can guess what this is. I guess we'll have to ask Joe to guess because he's the one who's right there.
All right. That looks like a familiar piece of material that we saw in the presentation.
This is the parachute from the presentation. This thing and the box, they went to 70,000 feet in Earth's atmosphere and they came back down safely.
Very, very cool. Well, like I said, I love that demonstration of the sugar because I visually, to show what would happen to something like that in the atmosphere, that was a pretty good demonstration just to show how different that atmosphere is. Before we do get to questions, if you are tuning in via YouTube, don't be shy. Use the chat sidebar and get those questions in. I thought I'd pull together a quick little Kahoot quiz behind the scenes while Sarah was presenting. So we're going to test some of our new knowledge. I'm going to share my screen here, and then maybe we'll play a little bit of Kahoot together. So this should come up now. There we go. If you want to join us today and you have one-to-one tech at your seat, maybe a Chromebook, maybe a tablet, you can go to kahoot.it, and it's going to ask you for a PIN number. Today's PIN number is 5865594. Now, if you can't join at your seat, a lot of classrooms don't have one-to-one tech. It's already up at the front of your room right now. So you could shout out your answers to your teacher and see how you do as a class. But if you can join us, like I see we've got a couple groups starting to join in, great. Come and join us in that way. If you're at home, there's a QR code there. So scan that QR code. It will bring you right in on a tablet or a phone. While we wait for our groups to settle, I've got a couple questions here. First question here is from North Collins Elementary School, Sarah. And they're wondering roughly how old is the planet of Venus?
Well, we think that it's like if you have a twin, they're about your age. So we think that Venus is the same age as Earth, basically, which is about 4.5 billion years. Billion. So very old.
Yes, absolutely. Very, very cool. Let's see. Okay, so this is a group, I believe, in Canada, in Fergus. And they're wondering, Miss Collins' crew is wondering, what is that, the first model you showed us, what is it going to be made of so it doesn't burn up or melt in Venus' atmosphere?
Well, what it's made of matters less than what it's coated with. Just like if you're cooking and you spray the pan, it has to be coated with something special. And to be fully honest, the recipe cannot be revealed. I don't even know what it is.
All right.
But it's some type of special carbon material. So it's a very special, like, woven material, and it gets infused with more carbon and baked heavily. So what the outside is coated with is what really matters, so it won't burn up. And it's a special kind of heat shield that is secret for the company, and we don't know what it is exactly.
All right, secret recipe, pretty cool. Okay, well, I think we're ready to play some Kahoot. There's some true or false, there's some multiple choice. As always, the quicker you get your right answer in, the more points you're going to get. And for the multiple choice, I put a few extra seconds in there because a little more reading for the multiple choice. So here we go. Let's see who comes out on top. We've got about 3 seconds that'll count you in. And then remember to listen and read the questions carefully. So coming your way first, multiple choice. Venus is the blank planet from the sun. Is it the second? Is it the fourth? Is it the sixth? Or is it the eighth? So if you're studying space, this is something you've definitely talked about in our solar system. So this should be a nice warm-up question for you. So Venus, the second, the fourth, the sixth, or the eighth planet from the sun. You've got 10 more seconds to lock something in, and then we'll see how we do. All right, good job, crew. Overwhelmingly, we went with the second planet from the sun. We know Mercury is the closest, I believe, 88 days to orbit around the sun for Mercury. So obviously longer for Venus, and we have our 365 here on Earth. Let's take a look at our podium. The Rockstar Beetle holding down that top spot. And a reminder too, don't be shy to put more questions in the chat. We've got a few in here, but I'd like to see a few more coming in. Then we'll visit a camera crew as well. So true or false, about 50 kilometers above the surface of Venus is the right temperature for life. So what do you think? True or false? A little quicker for this one. You've got about 13 seconds to lock it in. 50 kilometers above the surface of Venus is the right temperature for life. All right, absolutely true. As you get closer to that surface, no life we know of could survive in that environment. Although we have extremophiles here on Earth, but I imagine, Sarah, Venus is just too hot for any extremophile we know of.
Too hot and too acidic in the clouds and too hot at the surface, correct?
All right. Let's see what that did to our leaderboard. Rockstar Beetle holding on. Another true or false coming your way. The clouds around Venus are made of water, like on Earth. What do you think? The clouds around Venus, made of water like here on Earth. Water vapor. True or false? 10 seconds to lock something in. All right, couldn't fool you guys. False is absolutely right. Sulfuric acid for the clouds around Venus. Let's go to our next question. Rockstar Beetle is not going to let go, but it's still really close. 1 point. 1 point between first and second. So Thrilling Crane, you got to be fast on this one. I will give a little hint. This one's going to be a multi-select. So you need to select 2 if you want full points for this question. Sarah talked about building blocks of life that could potentially stay intact in sulfuric acid. So there were 2 of them that were mentioned. Were they DNA, RNA, amino acid, or lipids? You need to pick 2 of these as quickly as you can in our 1 point dash to the finish. Which two are you going to pick for staying relatively intact? DNA, RNA, amino acid, or lipids? You've got about 7 seconds to lock something in, and then we'll take a look at our podium. All right, a bit of a spread, but it looks like we had amino acids and lipids holding pretty strong there. Let's see what that does to our final leaderboard. In third, oh, the rockstar beetle bumped down to third place. Second, the snowy jellyfish. First place, anything can happen. Thrilling crane coming in for a thrilling victory right at the end. Very cool. If your class is the thrilling crane class, let us know in the chat. And let's get more questions coming in here. So let's get into the Q&A portion today. I'm going to turn off our Kahoot, shut down that music. And we're going to meet a classroom here and then grab some more YouTube questions. So joining us today, maybe not too far from you, Sarah. In Salem, we have the Phoenix School hanging out with us. So I'm going to see if I can get them here into the call. Phoenix School, if you are back there and you want to unmute, we'd love to grab some questions from your students. All right, Phoenix School, if you can hear and see me, send me a message in the chat and just let me know. We'll get you unmuted and we'll get you in here. Oh, I think we got them. There they are.
Hi, guys. Hi, my name is Jay. I'm in 7th grade, and my question is, how do you know what the clouds are made of in Venus? Like, could they be different?
Well, we have two separate ways, but there have been missions that have gone to Venus in the past, and they're using, it's kind of complicated, but they're using a light scattering method. It turns out that if you go and shine a light, like at dust particles or raindrops, they don't scatter equally in all directions. Like you have who has seen a rainbow? Like that rainbow is special to water droplets. Sulfuric acids will not give the same kind of rainbow. So there are missions that also went down in the clouds and shone a light and like measured the scattered radiation. And that's how they found out what it was made of. It's kind of complicated, but yeah, gone into, and they also use ground-based telescopes to do similar observations of the clouds.
Yeah, and I think with some of our instruments looking for exoplanets, we're trying to do the same thing with atmospheres of exoplanets, something similar, looking at the spectrum and trying to figure out what they might be made of, their atmospheres. Very cool. Okay, Phoenix School, if you have another question, let's get you up here for one, or I can come back, but I do see some hands, so we'll get someone up here.
So my question is, does the chemical compound in the clouds also affect the greenhouse effect in Venus, or is it mostly just the atmosphere?
That's an excellent question. It's mostly just the atmosphere. The clouds are reflecting light, so if anything, they're going to make the planet cooler. The atmosphere is very strongly absorbing. It's almost entirely carbon dioxide. On Earth, we only have a tiny, tiny amount of carbon dioxide, like a few hundred parts per million, but on Venus, the entire atmosphere. So it's just the atmosphere. Good question.
Thank you.
All right, great question. We're going to come back your way. We'll see if we have a follow-up or two in a moment, but I'm going to go back to YouTube. Okay, so this class is wondering about possibly transferring something like plants to the clouds of Venus. Could they potentially survive?
No, because remember, our DNA cannot survive because it has a sugar molecule, and we watched the video of what happens to sugar. So our plants would not survive because they also have DNA. All plants have DNA, so no.
All right. I have a class here in Ohio, and they're curious about the data coming back. So I think we had a few Mars speakers, and they talked about, I think it was somewhere around 14 minutes. Maybe been a little bit more for transmissions to go back and forth. What would it be like on Venus?
It's just a few minutes. It's just a few minutes or less to get data. But we don't have time to talk to it. Like, you know, if there's a rover on Mars, people here on Earth like send commands and receive info. This is just all happening automatically. It's going down, it's sending it back. So just, yeah, a couple minutes.
Cool. Another question here about commercial space exploration. So these missions are obviously outside of NASA, outside of the European Space Agency. And so do you think that's something we're going to see more and more is, people like yourself, groups getting together and funding these missions?
We'll see. We're trying to start this new way of doing it, but it's not clear if it will work. Missions are very, very expensive. So we're not really sure if it will take off, but we're trying. We're trying to set like a new example of, instead of having giant missions that are incredibly costly, to have cheaper missions that perhaps we could stir up some private interest or companies, working together, countries rather, working together to do this, other countries working together to do this. So I hope so, but we'll wait and see.
Okay. This is from a class in Oakville, Ontario. And they're wondering if anything you've worked on in the past, whether it's an instrument or a mission, has gone either into space or to orbit something else.
Well, I've had two missions. One is a CubeSat mission, a tiny telescope that I developed the idea, brought it from concept to launch. Ultimately, we worked with JPL. So we did like half of it. We solved all the hard problems. We teamed up with JPL. And it was intended to be a prototype for like a constellation, because if you want to look at the whole sky, you can't have a single telescope. We want to look at all the brightest stars like the sun, looking for another Earth. So we did that. It orbited successfully for 2 years. I also was one of the top 4 people leading a mission, a big MIT-led NASA mission called TESS, like the girl's name. And that mission is still orbiting Earth. So I've done 2 missions. And they're still orbiting Earth. One is still orbiting, one burned up in the atmosphere, but not yet one further away.
Now, Sarah, for classrooms who might not be familiar with a CubeSat, can you tell us a little bit about that?
Yes. Well, space is so expensive and complicated, but everything's custom. It's as if you were going to build some Lego, but you had to like build the Lego pieces themselves and then put them together. So a while back, maybe 20 years ago, maybe 25, some people thought, what if we make a standard form? And that one cube would be 10 by 10 by 10 centimeters, so a cube about this big. And what that enabled was universities and small groups, even sometimes a high school, to build these, because now all of a sudden you didn't have to put it all together from scratch, but you could just purchase components and put them together. And this phrase like CubeSat became a kind of thing, a way to make cheaper missions happen. So that's what a CubeSat is. But you can have more than one cube, just like with Lego. You can build something or you can attach things together and make it bigger.
All right. Phoenix School, if you do have another question or two, turn your camera on backstage. That'll be my clue that I need to come visit you again. But in the meantime, North Collins Elementary, Oliver would like to know, is there acid rain on Venus?
Well, wow, what a good question. So the rain never reaches the ground because it gets so hot that this rain will not hit the ground. It will literally evaporate well before it gets to the ground. So you could say there's very slow, gentle rain, but only if you could be in the clouds. It'll rain, and then just below the clouds, the rain will evaporate, poof, before it hits the ground.
All right. Sarah, why do you think that Mars gets so much more attention than Venus? I know obviously Mars is relatively close, so for sending messages or missions, but Venus is even closer. Why do you think Venus doesn't get quite as much attention?
I do like that idea, but before I give my opinion, I'd like to say this. Some of you, I know a lot of you will have a sibling, and Joe, I don't know if you had siblings growing up, but you know how in a family, there's always that one kid who gets all the attention? That was like my sister. I was the one and then there's the kid who like no one really pays attention to. It's kind of like that. Mars is basically the sibling that got all the attention, and Venus is the ignored one. But if you're that ignored one, you matter. I think what happened was when the last series of missions, like in the 1970s and early 80s, went down into the atmosphere, I think they just thought Venus was super boring. And they thought it can't host life, and we humans can't go there. And so I think those two things, not being able to have life and humans not being able to ever go there, I think that's why it got shelved as uninteresting.
Yeah.
But in fact, it is so interesting, just like the kid who's getting ignored because their sibling gets all the attention. There's something really interesting about Venus. There's a lot of unexplained chemical mysteries on Venus. And now we're just trying to get that sister planet back up in the spotlight.
All right. Phoenix School, let's get you back in here for a question or two.
My name is Gavin, and I am in 5th grade. And my question is, you talked about the test missions. What exactly are those?
Well, the TESS mission is a mission that's searching for exoplanets, planets orbiting around stars other than the sun. And the TESS mission is 4 cameras. Each camera has a lens about this big, and they're bolted to a platform. And each of these 4 lenses is on a spacecraft, and that spacecraft orbits Earth in a very elliptical orbit. And the TESS mission stares at a giant patch of the sky for a whole month, and then it moves on to another patch the next month, and over again for like a decade or more. And it's looking for planets. It's looking for exoplanets. And how it's doing that is TESS looks at like 1 million stars at one time. And we have our computers look at all those stars. And you know how stars just shine? They shine brightly. Well, we're measuring how bright is that star every minute or so. And we're looking for a tiny drop in brightness. If there's a planet that happens to go in front of that star, as seen from our viewpoint, like over and over again, we literally can measure a tiny drop in brightness. And TESS is looking for planets, and it's found like 100 confirmed planets, and it's found like thousands of planet candidates.
Pretty cool. Sarah, I know the number is constantly changing, but where are we roughly in exoplanets found?
We probably have thousands, well over 5,000 found. And there's different levels of found. Like there's some confirmed, legit, and there's some that are likely, but they're just kind of waiting to get confirmed. So there's thousands. And we think in our galaxy alone, there are going to be trillions of planets out there.
All right. Phoenix School, do you have one more to wrap us up for today?
Hello.
So you mentioned NASA and the European Space Agency, and I'm just wondering, because obviously, and you also mentioned the former Soviet Union's space agency, which is now the Russian Federation Space Agency. But do you know if the Chinese Space Agency and the Russian Space Agency are doing a lot with different planets? Because, I mean, it's probably because we're like on the other side of the world too. But...
Yeah. So as far as the Russian Space Agency goes, I don't know what they're doing. We don't think they're not the powerhouse they used to be in the Soviet days. As for China, we don't know what they're doing. And when it comes to space, we're actually not, just as a little thing, we're not allowed to work with China because although the scientists are our friends, like in terms of, politics, it's just not allowed. And space, not just civilian space science, but everyone's like probably spying on each other. So I don't know what the Chinese are up to. I've heard them say they want to find signs of life on Venus. So they could be cooking up a huge thing. So yeah, you don't know about them. We also don't know about what they're up to.
Okay. All right. Phoenix School, thanks for those great questions. Great to have you hanging out backstage with us there in Salem today. Always great to have your crew with us. So Sarah, $1 million question before we say goodbye for today. We always ask our space folks, especially those who are looking at Mars or Venus, looking for exoplanets or looking at the moons around Jupiter. How do you feel? What is your thought? Is there life possibly in our solar system or somewhere else? What do you think?
Well, here's the thing, right? As a scientist, we never want to speculate. We want evidence and cold, hard facts. So that's why in the laboratory, I'm trying to build the case to go to Venus and then find out. But if you want me to speculate, I think, of course, everywhere we look, we see the ingredients for life. Mm-hmm. It's so crazy that like even in the space between stars, we literally see we see the basic building blocks, the amino acids. We see tons of stuff. NASA brought part of an asteroid back to Earth, and they found amino acids and nucleic acids and tons and tons and tons of interesting molecules. So when you kind of put it all together in the numbers, it just has to be out there somewhere. But we're just trying to be scientific about it to make some real measurements to really find it.
Yeah, absolutely. Well, I mean, you just said, possibly trillions of planets in our galaxy alone. There's billions of galaxies. I find it hard to believe that it's just this one tiny little piece of our universe, life developed in some form. So I guess we'll see. There's been exciting possible biosignature on Mars, so we're excited to maybe get those samples back at some stage.
Well, I'll tell you what, I really hope that someone out there listening to this today is one of the people that gets to go to Mars. And I hope that one of you can go there and really get the search for life done for us with modern tools that you can bring there and be an explorer.
All right. Well, I want to start off with a huge shout out to our classrooms. Thank you for those great questions. Thank you for playing Kahoot with us. And Sarah, it was great to have you joining us and shining that spotlight on Venus. It's an important planet. We have lots to learn from it. So really excited to watch and see how those missions continue to develop. And hopefully you'll be with us to update some of those.
Thank you very much.
All right. Thanks, everyone. Have a great rest of the week. Hopefully we see you hanging out for Terry Verts tomorrow. Otherwise, next week, lots going on. So have a great week, everyone. And we'll see you again soon. Thanks, everyone.